Okay, just a minute. Okay, so suppose if I want to judge, as I discussed Rolle's theorem in the previous session, Rolle's theorem in the previous session, let us try to judge this Rolle's theorem for the function fx equal to x, where x lies between 0 and 1. Okay, now you see that if I want to test Rolle's theorem in this the criteria for Rolle's theorem in this particular function, for this particular function, we find that fx equal to x is continuous. Fx equal to x is continuous at in the interval 0 1. Okay, derivative f dash x exists at each point in the open interval 0 1. So two criteria are satisfied, but f0 is equal to 0, but while f1 is not equal to 0. So the third criteria of Rolle's theorem, that is, the third criteria was fa is equal to fb is equal to 0. This third criteria is not getting satisfied. This third criteria is not getting satisfied, and therefore this function, by Rolle's theorem, we can say that this function doesn't have any extremity in this particular interval. Okay, so that is another perspective by which we can study it. So Rolle's theorem is not being satisfied for this particular function. Okay, now that is one very brief example of Rolle's theorem which I have shown you. Now let us try to let us try to move on to the next theorem, which is called a mean value theorem. After that, I'm going to do one or two problems on the basis of this. Mean value theorem is actually the further generalization of the Rolle's theorem. And the mean value theorem, this is the actual the ultimate part, well, not ultimate, actually I shouldn't use that word. This is the main portion of which I need to discuss a lot, because in your syllabus mean value theorem is there. Rolle's theorem is also a kind of mean value theorem, but this mean value theorem which I'm going to write over here, it's actually a generalization to that. So the theorem, mean value theorem, goes like this. Suppose that f is continuous. Suppose that f is continuous on a closed interval I, and that f has a derivative in the open interval AB. In the open interval AB, then there exists at least one point C in AB, at least one point C in AB, such that FB minus FA is equal to F dash C into B minus A. That is the Rolle's theorem. That is the mean value theorem. Suppose that f is continuous. If you want to, if you want to compare mean value theorem with Rolle's theorem, so you will see that what are the conditions, actually what are the conditions uh, in mean value theorem present, and what conditions are present in Rolle's theorem. In Rolle's theorem, the first condition was a function is continuous on a closed interval. So it is also present in mean value theorem. In Rolle's theorem, it was there that the function has derivative in the open interval AB. So it is also there in this particular case. But one extra condition was there in Rolle's theorem, that if fa and fb equal to 0, then at least one point C is there for which f dash c equal to 0. But here you see that point, that particular extra condition is not imposed. Now, if you have this general view that fb minus fa equal to f dash c into b minus a, okay, then you see that and at this point, at this stage, if you put at this stage if you put the condition, if you put the condition fa is equal to fb, then one gives equation 1 gives fb minus fa equal to 0, and that implies, I'm writing over here, that implies f dash c equal to 0. That implies f dash c equal to 0. Okay, so actually Rolle's theorem comes from the mean value theorem. Rolle's theorem is a special case of mean value theorem. So actually, you see, that is the thing, and therefore, when the way by which it was derived, actually, first of all, the Rolle's theorem was studied, and from that Rolle's theorem, the mean value theorem was actually tried to they tried to find out some generalization of the Rolle's theorem, and they actually hit upon the mean value theorem. So we can derive a mean value theorem, we can derive Rolle's theorem from the mean value theorem by putting this extra condition. So actually, Rolle's theorem, although it was stated first, Rolle's theorem is a special case of mean value theorem. Okay, let me show you one example of the Rolle's theorem, mean value theorem. First of all, let us do a problem on the mean value theorem. So let me give you a problem. Question number 1. Question number 1 says that consider the function, gx is equal to sine x. Consider the function gx equal to sine x using mean value theorem, show that minus x less than or equal to sine x less than or equal to x. Okay, so that is the problem which I'm going to solve right now. So solution, the function gx equal to sine x, the function gx equal to sine x is given. Okay, we consider the interval, since now you see, the first of all, to find out the criteria which is given over here, you have to think about the interval of the function. So since no interval is given, is actually mentioned in the problem, so you have to design your own interval, and that is the, I think that is the hardest part of the problem. I mean, if you can design the interval properly, then you will be able to get this particular inequality. But if you cannot design the interval properly, then the inequality will not come. So by practicing a few problems, you will be able to understand easily how to design that interval. So here in this particular case, the interval has to be considered like this, from 0 to x. Okay, since no interval is mentioned over here. Okay, and this can be done by a few trial and error method, by which you can find out the proper interval in which this particular inequality is being satisfied. So the interval is considered over here is 0x, and I have written this with a different color. Now after this, let us proceed. Now what do we find? That now sin x is continuous. Now sin x is continuous in 0x. Sin x is continuous in 0x. It is differentiable. It is differentiable everywhere. Differentiable everywhere in 0x, in the open interval 0x. You can easily check it. Now from mean value theorem, we get that there exists a point C in the interval 0x, such that gx minus g0 is equal to g dash c into x minus 0. Why? Try to recall the formula of the mean value theorem. It goes like this: fb minus fa equals to f dash c into b minus a. This implies sin x minus sin 0 is equal to g dash c, means you have to find out the derivative of gx and put the value at x equal to c into x. So this implies sin x, sin 0 is 0, and g dash x is cos x at the point x equal to c into x. And what is that? That is sin x by x is equal to cos c. Now we know that cos c lies between -1 and +1, and therefore sin x by x lies between -1 and +1, and this implies minus x is less than or equal to sin x less than or equal to plus x, which proves our desired result. So that is one of the examples of mean value theorem which I have proved over here. I have applied the mean value theorem on the function gx equal to sin x. The important part is this one: you have to design the interval properly so that this particular inequality comes. Okay. Okay, then let's solve another problem. Question number 2. Use mean value theorem to prove that use mean value theorem to prove that mod of sin x minus sin y less than or equal to mod of x minus y for all x comma y belonging to R. Okay, so solution of this particular problem which I have made for you. So let me give you the solution. Let fx equal to sin x, let fx equal to sin x be defined. Let fx equal to sin x be defined in the interval from xy to r. Now here you see that in the previous example I have selected 0x as the interval. Now in this particular case I have selected the interval as xy. The interval in which the function is being defined, I have selected xy over here. So that is the part which you have to think of. Okay. Now, before I solved this particular problem, I actually gave a little bit of trial and error to the problem to find out the actual interval. Now, fx equal to sine x is continuous in xy, and it is differentiable in xy, everywhere in xy, okay. So there exists a point C belonging to R such that and C lies between x and y, it's the interior point, and such that f of y minus f of x, fb minus fa, it is equal to f dash c into x minus y. Now this implies sine of y minus sine of x is equal to cos c into x minus y, okay, and that is equal to sine y minus sine x by x minus y is equal to cos c. Here we have assumed that okay, so cos c. Now you see that since we already know that cos c lies between -1 and +1, so this can actually be written as cos c mod of cos c is less than or equal to 1 by the definition of modulus function. So we can put the expression inside that, and you know that this can also be written as, doesn't matter if I change the direction, it doesn't matter if I write sine x and sine first and sine y second, because it is inside the modulus symbol. So I have just interchanged these two, which is less than or equal to 1. So this implies that mod of sine x minus sine y by mod of x minus y less than or equal to 1, and this implies mod of sine x minus sine y less than or equal to mod of x minus y. Okay, and this proved the desired result. So that is another example of mean value theorem which I have done. So I'm giving you some time to copy this particular problem, and then after 1 minute I'm going to start. So I can proceed. I hope that I can proceed to the next page, and let's do another problem quickly. Question number 3 says that use mean value theorem to prove that x minus 1 by x log x minus 1 for x greater than 1, and you can see in the exercise it is mentioned that use the fact that d of ln x equal to 1 by x for x greater than 0. You can see d is an operator which is called d dx, and which is a linear operator. Now to solve this particular function, let us proceed in the following way. Take your fx to be ln x. It is quite obvious, and they have also mentioned that you have to consider the function to be ln x. Then the hardest part, then we consider Then we consider the interval. Then we consider the interval x1. Okay, you have to think. I am giving you because I have solved the problem. Now the problem, I know that if I consider the interval in this manner, then the problem can be done. But actually, I also felt some sort of obstruction while thinking, because I have to lot of, if I show you my, if I can show you my copy, you will be able to see that okay, lots of calculations were there. I lots of mistakes, and I crossed it some portions, and then I actually added some other portions. So actually, I am saying that this particular portion is actually, I'm again and again saying this particular part is very important. If you can think it in a better way, then you will be able to reach to the problem sooner. Okay. So in which fx is defined, since for x greater than 0, the derivative of fx exists as d of ln x is equal to 1 by x for x greater than 0, then fx is differentiable, in x1, and fx is continuous in the interval, closed interval x1 2. So there exists a point C in x1, so that by mean value theorem, by MVT, we can write just a minute. No, I think I have to change this particular interval a little bit. Otherwise, the problem will not, I mean, you will not be able to do it. Let us change the interval to 1 and x. That is the thing I'm saying, 1 and x. You'll get to see why. Otherwise, you will not be able to, not x and 1, it should be 1 and x. 1 comma x. Okay. 1 comma x or x comma 1. What shall I write? Just a minute. Let me think. So it should be fb minus fa. Oh, sorry. My mistake. Previous one was right. X comma 1, and that is x comma 1. Sorry. Okay, so here in this case, I'm selecting this to be my A and this to be my B. Okay, then it is all right. By mean value theorem, we have, there exists a point C. By mean value theorem, we can say that FB means F1, F1 minus FA means FX. F1 minus Fx should be equal to F dash C, and that is b minus a, that is 1 minus x. Okay, now it is all right. So f1 is what? ln1, and that is what? ln x. Okay, and f dash c means 1 by x at x equal to c, and that is 1 minus x. Okay, so that is ln x, because ln1 log 1 is 0, and it you can write it as 1 minus x by c. And this can be written as minus ln x by 1 minus x, that is equal to 1 by c, 1 by c. And from this you can write c to be equal to 1 minus x by ln x, 1 minus x by ln x, minus ln x. Now as c is the intermediate point in x1, so c lies between x and 1, and x, in place of c you put the value 1 minus x by ln x, which is equal to which is less than 1, and that is 1 by x. You can interchange the sign. This should be ln x by 1 minus x. Because I'm taking the reciprocal, so inequality will change, and this implies 1 by x greater than ln x by x minus 1 greater than 1, and that is, you can multiply both sides by x minus 1. Since x is greater than 1, so remember x minus 1 is positive, and so inequality will not change, and we are going to get this thing. Okay, so was this the result which I no actually inequality has changed. I mean, this is not the thing. Actually, what is the lowest? X minus 1 should be the um some mistakes have been done. What is that? What this mistake? Something which I missed actually. What is that? I mean, the inequality, the form of the inequality has changed. What is that point? Okay, just a minute. Probably I have found it. Why this inequality has changed? It should be the opposite, but I have got you put your attendance, probably you put your attendance. I have enabled the chat box. See, actually I need to show this. X minus 1 should be on the right hand side, and x minus 1 by x should be on the left hand side. So here actually the inequality has changed. The form of the inequality actually has changed. Okay, Abhipriya Ghosh, you want to say something, no? So unmute yourself and you can say.
Sir, in the next page where you're changing the sign, then you're changing that means inequality. I could not understand how.
Which one?
Adjacent line, sir,
Oh,
minus.
yes. Thank you so much. That is the thing. Oh no, I actually know. That is this part you are saying about. This part.
Yes, sir, means x minus 1, it is becoming positive, means that's why sign is not changing.
Yeah, I mean whenever I'm multiplying the inequality by x minus 1, you are
Sir,
talking.
no, sir, the problem is that in the third line, when you are multiplying the total by no, means the minus.
Yes, so you are also I mean I know that you are also finding difficulties in actually you are also not able to find the mistake. Uh, you are saying two things to me. One thing,
Sir,
bolo.
so in the question you gave x is greater than 1,
Hmm.
but in this page you wrote x is less than c is less than 1.
Oh, acha, let me change it. Okay. Just a minute. Just a minute. Okay. I understood. I think that is that's why I actually became confused a little bit. Yes. That is the part which I have to deal with. This is the thing which created the problem. That's why I thought ki something is missing. I mean something I'm doing wrong. X is greater than 1, so should be 1 and x, and that should be 1 and x. Let's see what happens now. 1 and x and 1 and x. Okay. If it is so, then quickly let us change these things. I can write it as fx minus f1 f dash c and x minus 1 x minus 1. Okay, x minus 1, and therefore that would be fx means ln x, so it will be positive, and that would be minus ln 1. 1 by x equal to c is all right. It should be plus 1 and minus 1, and that should be x minus 1. Then that will vanish, and it should be ln x plus ln x, and it should be x minus 1 by c plus ln x by x minus 1 is equal to 1 by c, and that would be c would be x minus 1 by ln x. C would be x minus 1 by ln x. Okay, let's see what comes now. Now in place of c, if I, so let us change this. It should be I mean, okay, and therefore in place of that we can put the value of c. What was that? Was x minus 1 by ln x. Okay, x minus 1 by ln x by x, and then okay, this implies if I change, if I take the reciprocal, then it would be 1 greater than ln x by x minus 1, and this should be x, 1 by x. Okay, and since x greater than 1, so x minus, this implies x minus 1 greater than 0, and therefore we can multiply all the sides by x minus 1. So we get, yeah, now it is all right, x minus 1 by x. Who I am very much I thank that student who actually helped me to rectify this particular thing. Okay, what was your name? The student which identified this problem? No, Nikita Singh has written that when you said, you told that FA equal to F in Rolle's theorem, but I'm not actually applying Rolle's theorem now. I'm applying mean value theorem. So in Rolle's theorem, it should be FA and FB should be equal to 0. If you want to apply the Rolle's, if you want to test the Rolle's theorem. Okay. So yeah, so Nikita actually helped me to find out the actual trouble. Actual trouble was there in this particular part, in designing this interval. Here in the question, x greater than 1 was there, but I put x as a lower limit and 1 as upper limit, and therefore the problem occurred. So you see, your result is now ultimately proved, and we have so far done applied mean value theorem in 3 different problems. Okay, so this much for today. I'm not going to take any further session. This is my last session of today's class, and yeah, I took x minus y minus x in place of x minus, but I did it inside the modulus sign. In modulus sign, mod of -1 is same as mod of 1, so you can interchange the you can interchange inside modulus, you can interchange anything. Okay, so okay, let's say she's pointing out something. Let's see which particular line. Sin y minus sin x by x minus y. Oh, okay. I understood your point. I understood your point. I understood. These are the mistakes actually. Y minus x, and now it is all right. I think that is the thing you are talking about. Yeah. Okay. These are the kind of mistakes actually. So you shouldn't do this kind of mistakes in the examination. I can do it. I can rectify, but I think now, Nikit, you are happy that this is the problem you are talking about. That has been rectified. Asking other people to rectify that thing also. That means yes. Okay, that means you are doing it carefully. You are doing the problems carefully. Actually, fine. Thank you so much. You have marked 2 mistakes in the calculations. I am very much thankful to you. And that this problem is very important. Actually, this problem is very important. So in the next class, we shall try to discuss further on mean value theorems. And my next class will be taken maybe on Tuesday or Wednesday. That will be discussed later on. My Thursday is fixed, but my Tuesday and I actually my Tuesday and Wednesday is actually volatile, it's fluctuating. So I'm ending my class over here, and I shall upload all the videos in the YouTube. Once my network is stable, you are going to get all this in the YouTube video. So bye for today. Hope to see you soon in the next week. Meanwhile, you keep on studying. You study other subjects also. That those subjects are also very important. And bye for now. Okay. Thank you so much for attending my class.